So the video got cut off just now because I ran out of space, but we can try that again. So let's turn on the sockets and let's start streaming data again. So once again, assuming someone walks by, a short feed is basically sent of the person walking by. You can see two streams are actually being sent. So we're getting about 10 frames per second, but that's because we're streaming two sets of video over two sockets, and we are also calculating the contours at the same time. So we're getting about 10 frames per second, but usually we get about 30, assuming the second video wasn't sent. So let's just take a look at the code. So for the iOS side, I'm basically using the OpenCV libraries as well. However, I wrote my own socket protocol. I wrote my own socket streaming structure, which is basically streaming the frames 8 bits at a time via UDP port. And basically it's great to do this in iOS because you can write C++ code, which makes porting very easy. So you can see the socket being open. You can see a stream being set up via GCDQ. We can see the sockets being open, and then we can see the frames that are being received and generated. And finally, after creating a mat OpenCV object, we can convert that to a UI image using a couple of the CG libraries. So yeah, and eventually after creating the UI image, that is pumped via the main thread to a callback function, which then prints the image on a UI image view. So that's the iOS side of stuff. On the BeagleBone, I basically have a basic Linux program set up. So essentially there are 4 threads that are running. These 4 threads represent 4 different things. One of them is basically reading the serial data from the Arduino. The other one is reading from the camera, reading the frames from the camera, and the last 2 are basically queues that receive the image from the camera. And once they are received, they're basically woken up and the image is pumped via multiple sockets. So if you take a look at the camera thread, you can see the frames that are being captured, and the number of frames that are captured for someone walking by is set right here. And you can see that once that is done, we save that frame to a queue, and the other worker threads here basically pick those images off the queue and they are sent via a socket, which is then received in the iOS app. As for the Arduino side, is essentially doing a bit of filtering of the analog data stream that's received, and it's basically calculating if someone has walked by or not based on states that are registered in the code. So the reason why I didn't hook up the IR sensors directly to the BeagleBone is because the IR sensors output a 0 to 5 volt analog data output, and I didn't really have the logic level converter for that. I didn't have enough pins on the logic level converter, so I just used the Arduino instead to feed the data directly. But this code can be easily ported over to the BeagleBone as well. So yes, that's pretty much the demo. I'm just going to showcase the streaming one more time. Program. Someone walks by and we get the video stream, which then can be saved. So you can see the use case for this. Using the contours, we can also we can do processing of the image to then determine the number of people that have walked by. We can also capture and save the video stream. If say there was a robbery or something at a store, you can actually pick out the exact time at which the image was saved. So this socket system could actually be set up on a server, which then the BeagleBone can stream to via the Ethernet port. So yep, that's my demo. Thank you.